All right, so we're continuing on with example 5 in section 7.6. If you recall, example 4 involved two shims of different thicknesses, and we had to write an equation with two variables. That's kind of what's happening here. In fact, it's about shims of different thicknesses. So we have two shims that have different thicknesses. So I want to establish some variables to represent what it is I don't know. So when it says what are the thicknesses of the two shims, I'm going to go L is the width of the, or the thickness of the larger shim. And let's go with S is the thickness of the smaller shim. X and Y works also. Just whatever variables you're going to choose to use within your problem, make sure you identify what those variables mean so that as you work through the problem, you have an understanding of what those equations mean. Now, first thing says a machinist needs to use two shims with a combined thickness of 0.084 inches. So combined thickness implies we're going to add the thickness of the two shims in order to get the entire combined thickness. So that's simply going to be the larger shim's width plus the smaller shim's width equals the total combined width. The other equation, it says one shim is to be 3 times as thick as the other shim. One shim 3 times as thick as the other shim. Okay, and because I used L for larger, S for smaller, I got to multiply one of these things times 3 to make the other thing. That's what it says. One is 3 times thicker than the other. Does it make sense to do 3 times the larger to make the smaller, or 3 times the smaller to make the larger? 3 times a small number makes a bigger number, or 3 times a big number makes a smaller number? What makes more sense? 3 times smaller, right? So, large equals 3 times small. So there's my system of equations that I've got written there. So I've got two variables. I don't know anything about either one of these things. So if they said, hey, the larger shim is this big or the smaller shim is that big, one equation would be sufficient. Since they didn't give me either width, I needed two equations to be able to solve this problem. This is the extent of what we did yesterday in example 4, a problem very much like this, but now it actually wants us to work it out, to figure out the answers. Like what are the thicknesses of these two shims? So now I'm going to use a technique called substitution. The way substitution works is the letter L is in this equation up here, and L has a different version in the other equation. So this is telling me L and 3s are equivalent to one another. They equal the same number. If L is 5, then 3s is 5. If L is 10, 3s is 10. They are the same thing. So I can replace L in this equation with 3s. And if I do that, this black equation, which is right here, is going to transform into this blue equation up here. The only modification I made, let me just use a highlighter here to really reinforce what's going on. I changed the letter L to 3s because L equals 3s. The rest of that black equation did not change at all. Plus S is still plus S, equals 0.084, still equals 0.084. The only modification was L became 3s because L equals 3s. Once I do that substitution, now I've got an equation with only the variable s in it. So now adding the equation, or adding the like terms up, 3s, and this officially is 1s. And 3s plus 1s makes 4s. And then good algebra tells me if 4s equals something, and I want to know what s equals, I divide by 4. So the smaller shim would be 0.021 inches. Feel free to use a calculator to calculate, but again, it's just division. The 0.084 divided by the coefficient 4. It says what are the thicknesses of the two shims. That's one of the two shims. The other shim is L. And L is equal to 3 times S. So 3 times S, but S is 0.021 inches. So we multiply 3 times 0.021, we get 0.063 inches. So if I have two unknowns, I need two equations to be able to solve unless I'm told something else. So expect problems of that variety to show up tonight.